Hello, dear students. Welcome to the channel and very welcome to this playlist in which we are discussing about IoT. And in previous class, we have discussed about basics of IoT, what exactly is IoT, and what are the different sectors or different areas where IoT is one of the major applications. We have discussed several areas and several sectors where IoT is very essential, and we have seen how the IoT is becoming a ubiquitous technology which will be used almost everywhere in very near future. So that was basics, and that was pretty much understanding of IoT in layman's term. So if you haven't checked out that video, please click on the top right hand side corner of your screen. The I button will be showing you the direction of that video, so you can click on it and you can watch that video in case you haven't. And now today we are going to discuss about the technicalities of IoT from an engineering perspective. So today we are going to talk about high level architecture of IoT, or the technical different building blocks which forms the IoT structure. So just see this block diagram over here, which shows you two-way arrows. Right, it shows two-way arrows. One way is for the flow of the data, another way is for the flow of control. First comes the cloud services and applications. It connects with the edge infrastructure, then it connects with IoT gateway, and then IoT gateway distributes it to your IoT devices. Right. So basically, whatever action that has been taken, that action is performed by cloud services or cloud applications. There are so many cloud services, applications available these days. Then it comes to edge infrastructure, whatever infrastructure is used, and then you will be provided IoT gateway. We are going to discuss about them in detail, so no worries. And that via that gateway you become eligible to use internet of things in your to day life with the help of your devices, your different sensors and actuators that you use. So these four blocks are major components of IoT. And there are so many IoT devices like thermostats, cameras, watches, your vehicles, cars, refrigerators. All these devices continuously record and track various data as per their design and as per the requirement of the user. For example, if I want to say, your smartwatch will continuously track your pulse rate, just like we discussed last time yesterday. And these devices have various connectivity options, like it can have Wi-Fi, it can have Bluetooth. If you are old enough, it can have Zigbee, right? But to be precise, this IoT device typically have sensors and actuators. And what are sensors and actuators? We are going to discuss about them in detail today. So first, let's talk about sensors. I think sensor is very common word these days, and you all might have heard about sensors in one way or other. You all have seen few of the sensors, or at least have heard about some of the sensors. So sensor is basically a device that responds to a physical stimulus. Physical stimulus can be heat. It can be a heat responding sensor. It can be light responding sensor. It can be sound responding, pressure responding, magnetism responding, or any kind of particular motion responding thing. Right? It can be anything. It must have to be physical stimulus, and it transmits the resulting impulse as well. Right? So, for an example, if your pulse is getting if your pulse or your heartbeat is getting recorded, then what is it? it is kind of a motion, it's kind of particular motion, right? So it is getting measured and then transmitted to your resulting impulse, or to your server or cloud, or your phone, right? For your watch, your phone is the basic uh, first gateway of the server, and it responds to it, it records it, and it sends the data to the phone, right? And it does it all as a measuring of operating a control, right? It can do it all as a measuring, or it can do it all as a operating a control. And based on that data that you collected on your phone, it can also arrange your sleep schedule, or diet chart, or anything. It can assign you these things, right? So if I want to talk it out in engineering terms, then sensors basically read the various stimulus and then sends them to processing system for deriving the actions to be taken, right? And if I ask you what are the common examples of sensors, then fingerprint sensor is something that almost everyone has heard about. Thermometer is something that you all have heard about, or you have seen, you have used. Then I can say, if you are using smartphones, then you will see a proximity sensor in your phone. You are using it almost in everyday life. There are humidity sensors which measures the humidity. There are so many type of sensors which we are going to discuss about, but these were the basic examples of that, right? Take whatever sensor you want to take the sensor as you sense organs, with the help of organs like eyes or ears. That organs can be sensed with the help of sensors as well, right? Because what does eye do? It can see it. What does ears do? Listen to it. It makes you which makes the sense of the world around you. Your eyes can sense the light. Ear can listen to voice. It can respond to sound signals, right? So basically, your eyes and ears are also a sensor in their own way. It allows you to sense the environment around you. Your eyes and ears. Your tongue is also a sensor. Your tongue allows you to taste and tell you how does that thing tastes like. Your nose allows you to, it does not only allow you to breathe, but it also allows you to smell something and decide if that food is ripe or not, right? So all these things are sensors. Now if that is sensor, then what is an actuator? You all have heard about actuator, right? So speaking from definition point of view, actuator is basic mechanical device which used for moving or controlling something. And the classic example is robotic arm, right? It is a device which is used for moving something or controlling something. It can be a switch because you control it. It can be a valve, it can be a sound alarm, it can be fire alarm, it can be anything. Anything that carries out desired action as directly by the controlling system is basically your actuator. So in your human body, you can take your hands and legs as an actuator based on uh, based on the command which has been assigned from your brain. You make your desired movement with the help of your hands and legs, right? Brain is the server of uh, if we compare human system with computers, then brain will be the server, right? Brain is something that processes the signal which is received from your sense of organ like eyes and ears, and then gives the command to your hands and legs to work accordingly. Like for an example, if you are walking in the alley, or if you are walking on the road, and all of a sudden a car comes in with the full headlight on, then there will be your eyes will see there is too much light coming up from the front, and it will tell your brain, oh, there is too much light. Then what you will do, you also want to see further, you because you have to walk. So what you will do, you will get your hand uh, the in the line of that light, and you will block that light with the help of your hand, and then you will move further, because you cannot close your eyes, you also have to move ahead. So your what did your hand do? It actuated, it is an actuator here, right? So another example, if the room temperature goes beyond a certain limit, you can use an actuator, and it can automatically power on or power off your AC, right? That would be not in human, that would be different. And when we put together your sensor and actuator in an operating environment, you can achieve better very good results. Like a thermal sensors, which measures the temperature almost every second, can send the room temperature to the IoT system, right? And that IoT system that processes the temperature input to the in order to find out the temperature, if either it is rising fast enough to ring the fire alarm or not. So by coordination of both actuator and sensor, you can achieve your desired operation in the IoT. Except for sensors and actuators, we have IoT gateway. We have talked about IoT gateway as well, right? Actually, we are going upside down. First, we've discussed about sensors and actuators. So look at this diagram. We are having IoT devices as sensors and actuators first. Then we will talk about IoT gateway now. Then we will move to edge infrastructure, and then cloud services and applications. Because which flow we are considering? We are considering data flow right now. The control flow will be completely reversed than that, and how we will see that as well. Now we have IoT gateway. So there could be several IoT devices in industrial settings, right? For example, if you are using a car which is connected to your different devices or different things, then there could be several cars on the road from the same manufacturer, which would be connected to different things, right? If your car, for an example, take GPS, if your car is connected to the GPS, then there will be a number of cars that would be connected to the GPS as well. So if all cars are connected to the GPS, then how would you identify, how would you send the signal? So the different data points from your connected car or connected vehicle, like engine heat, mileage, driving style, and so many other car performance related parameters, could be tracked by manufacturer for providing preventive maintenance and breakdown support. And in order to optimize the number of direct connection to the devices, the IoT gateway is used, right? Let me repeat it one more time. To optimize the number of direct connections to the devices, the IoT gateway is used. And what does it do? It aggregates the data from server connection, uh, the server connected devices, and then it processes them. But before that, pre-processing is required. Pre-processing itself is a different topic to discuss. But pre-processing is required so that only the useful or important information can be sent further, and we can rectify the non-useful or the garbage information, or we can call it noise as well. Sometimes we call it noise. So IoT devices could collect all this data in very less amount of time. It can collect data sometimes in the millisecond level, right? And such high granularity of the data may not be required to be sent further in its entirety, right? Remember, we learned in the previous chapter, we sample it. We send only samples, not the whole data. So IoT gateway thus processes the granular data from several devices, and then it will send to further communication device, send it to the further communication device, right? After that we had edge infrastructure. So the edge infrastructure is okay, let's start it from the start. Talk about edge infrastructure. Once this data which we have sent further, this IoT data is synthesized at my gateway, then it will be sent to this unit, edge infrastructure. And edge infrastructure will provide cloud computer records which will be closer to the user or you, to avoid the sending in order to avoiding sending large volume of data over the network, right? So you will be able to run analysis function, execute the predictions based on machine learning models. You can keep device data in sync and then communicate with other devices, right? And you can further filter device data and only send the necessary information which is important for the cloud. So edge infrastructure basically provides the cloud's computing resources which are close to the user to avoid sending large volume of data over the network, right? Then we have the cloud services. So after that stage the data can further be analyzed using cloud services and resources. And you could have several IoT based applications such as car predictive maintenance model you can develop, health monitoring, traffic monitoring, home automation, so many things that could consume data. And uh, that data from IoT devices can be consumed, and we can produce meaningful information out of that, right? And we can produce meaningful information and then work on it and get different actions done, right? Based on this thing only, there is a whole new stream which has been fabricated recently. We call it data science or data analysis. And even based on that, if you are familiar with computer vision, so basically computer vision is a thing, some vision is something that you in, give your input in form of image or video and extract some information out of it. So this is various forms of that as well, right? Even though computer vision is completely different than this, and it is actually a small part of artificial intelligence itself, but you can correlate, right? Then after that comes the network connectivity, because one thing that is transparent in the architectural diagram is network connectivity from IoT devices all the way up to the cloud services and applications. So without this network connectivity there is no internet, and if you don't have internet then there is no internet of things, right? So there could be several networking protocols at which various layers which provide seamless network connectivity to operate, control, and manage the IoT devices, and you can make optimum use of them, right? And so many of these connectivity options. 2G, 3G, 4G, LTE, 5G, Bluetooth, USB, Ethernet, Wi-Fi, Zigbee, NFC. All these are examples of network connectivity. It allows you to connect, right? These devices supports very wide range of network communication protocols. It supports HTTP, it supports MQTT, it supports AMQP, it supports COAP, and so many of them. Now that we have discussed about the architecture, high level architecture, let's discuss about the physical design of IoT, or how does it works, or what actually it is it. So each technology or protocol which described in this section which we discussed earlier, or which we are going to discuss, are itself a huge topics in themselves. Okay, we are getting very small glimpse. So we are getting very small glimpse of it, but I will walk you through them all in detail if you need to know, or if you need to build an IoT based solution. So as you've seen till now, things in the IoT could refer to the actual devices. Let me change the slide. Okay. So things in the IoT could refer to actual devices or equipments that perform specific sensing or actuating in function. And IoT devices are an outcome of combining the worlds of information technology and operation technology. So we are taking IT, where we are taking OT, and we are combining them. And so many of the IoT devices are actually the result of convergence of cloud computing, mobile computing, embedded systems, big data analysis, low price hardware, so many technologies, right? So basically, it is not one domain related field, it is conversion or accumulation of various different fields coming together and providing one optimum solution. It can provide computing functionality, it can give you data storage, network connectivity for equipment that previously lacked them. It can provide you the ability to enable new efficiency and technological capabilities for your equipment, like for an example, remote access for monitoring, configuration, troubleshooting. So many examples, so many applications. So it can also add the abilities to analyze data about the physical world, and it allows you to use the result in order to obtain better information, right? And it allows you to make better decisions eventually. It allows you to alter the physical environment of yours based on whatever thing you have analyzed. And you can even anticipate future events with the help of machine learning now. Though IoT and machine learning are different fields, I must mention that. But at a high level, there are three type of capabilities in IoT devices, which you can see in these three diagrams: transducer capabilities, interface capabilities, and supporting capabilities examples. Right. So you can see sensing and actuating falls into the transducer application interface or API, and human interface and network interface falls into interface. And then in supporting capabilities, we are having device management, cyber security capabilities, and private capabilities, which helps you secure your privacy. So now let's see all three of them one by one. First comes the transducer capability, which includes sensing capability and the actuating capability. So this transducer capability basically interacts with the physical world and then serves the bridge between digital and physical environments. And it provides the ability for computing devices to interact directly with physical entities of its interest. So every IoT device can at least have one transducer capability. And what are these two different type of transducer capabilities? The first one is the sensing capability. It is the ability to provide an observation of an aspect of the physical world in the form of measurement data. For example, you can take temperature measurement, optical sensing, audio sensing, or radiographic imaging, right? You can consider them. Then we are having actuating capabilities, which we have seen. So what you have for actuating capabilities? So it is ability to change something in the physical world, like turning on a light bulb, turning off the heater, automatically opening a door, right? Or even the things that you can do with the help of robotics. That all falls in the actuating capabilities. So these are the transducer capabilities. Then we have the interface capabilities. So these interface capabilities allows you to enable the interaction with IoT devices. So You can communicate to whatever device you are using. You can give your signal, give signal to your air conditioner to switch on or off on particular time. And not necessarily this communication is a device to device, right? It can be device to device communication, it can be human to device communication, or device to human communication. So, and it can even be external world to device communication where third party is getting involved. So there are multiple type of communication, and most of the communication, or I should say all the communication, falls into the interface capabilities. Three type of major capabilities we are having in the interface capability. First one is application interface. So application interface is basically ability for other computing devices to communicate with an IoT device through an IoT device application. For example, let's say a application interface capability is an application which is performing application performing interface, and this API or application performing interface are used extensively to instrument IoT devices for both receiving output and providing input. Second, we have human user interface. So human user interface is the ability for an IoT device and people to communicate directly with each other. uh, for example, you can say touchscreen mobile phones, cameras, speakers, microphones, right? It allows user to directly communicate to. And this is precisely how you can directly connect the IoT device to carry out an action such as saying, Alexa, uh, which song is trending right now? Alexa, what is today's how today's schedule looks like, right? And in case if you're living under the rock and if you don't know what Alexa is, Alexa and artificial intelligence of Amazon, which which can be your mini assistant, and it can do tasks based on your willing. Right, we are having so many of them. We are having Cortana in Microsoft Windows. We are having Siri in the Apple. So there are so many of them. We are even having OK Google these days. So there are so many of them, and based on that we can receive the response through the speakers. Alexa will tell you how your day will look like. Alexa will tell you which song is the trending right now. Alexa will tell you what is your favorite song. And uh, I'm just giving an example of Alexa. This video is not sponsored by Amazon either ways. Then we are having the network interface. Network interface is the ability to interface with communication network for the purpose of communicating data, or data to or from an IoT device. And this is what connects the IoT device to the network and makes it Internet of Things, right? So the Internet of into IoT comes from this network interface. So the capability of network interface includes hardware capability and software capability, both of them. For example, if a network interface card or a chip, and the software implementation of that networking protocol that uses that card or chip. Examples of network interface capabilities includes Ethernet, Wi-Fi, Bluetooth, LTE systems. LTE stands for long term evolution if you don't know, and Zigbee. And every IoT device has at least one enable networking interface capability, right? And if it wouldn't, then how it will be Internet of Things? So, and at least one, but it can be so many of them, not limited to one. And after that we have third one, which is supporting capabilities. So these supporting capabilities are not non-uniform. It's not compulsory to for your device to have it, but it depends on your application. So they have these capabilities provide the functionality that supports the other IoT devices related capabilities. And uh, the classic example of this is the device management. You can plan the deployment of some uh, deployment of your flight or something. You can configure, you can control, you can patch, you can update. All this falls into the supporting capabilities. Security, privacy, all this falls into supporting capabilities. And all these three capabilities work together to provide the seamless user experience to you. So that was the physical design or physical structure of an IoT. Now I want to discuss about sensors and actuators in detail. So about what are the sensors and what are different types of sensors. So basically a sensor can be of four types: active, passive, analog, digital. Active sensors produce output signals with the help of external excitation signal or power signal, and they do not generate any response until or unless activated by external signal, like LVDT or strain gauge. If you ever heard about strain gauge, I think you most of you will be familiar with. LVDT is basically a transformer, small, very small linear variable differential transformer, which gives you uh, the 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 change in small displacement. Then you have the passive sensors. This passive sensors produces output signal without the help of any external excitation supply, unlike active sensors. And these passive sensors don't have or don't need, rather don't need any extra signal or voltage, right? For example, you can take thermocouple. It generates a voltage value corresponding to the heat which is applied to it, but it does not require any external power supply. So that's your passive sensors. Then we have analog and digital sensors. Analog sensors will produce analog output only. That was pretty straight. So continuous output signal with respect to quantity being measured, that would be analog signal. And this analog output will generated the analog output generated is proportional to the measured or the input given to the system. And generally the voltage range of this analog output is from 0 to 5 volt. And as an output, most of these sensors will produce current. The various physical parameters like temperature, pressure, displacement, stress, etc. are examples for continuous signals. We all know that. And examples of analog sensors, what would be that? I think you would know. Light sensors, pressure sensors, speed sensor, accelerometer, temperature sensors, right? If you remember any more analog signals, please mention them in the comment section below. Then the fourth type of sensor will be the digital sensor. Digital sensor, in contrast to analog sensors, work with discrete signals or digital data, and the digital data or the data in the digital sensor, which is used for the conversation or transmission, rather transmission would be the better word, not conversation. Transmission is basically digital data in the nature, and that discrete signal will be non-continuous with time. And I think those who have followed this course would know. It can be represented with the bits in bits for serial transmission, that's in binary. And you can represent it in bytes as well. Basically 8 bits add up to form 1 byte, right? For parallel transmission we use bits and bytes. And digital sensors typically consist of a sensor, a cable, and a transmitter. So measured signal can be converted, I think Measured sensors can be converted into a digital signal inside the sensor itself without any external component. So you can use a cable for long distance transmission. And give me the example of the digital sensors. First that comes into my mind will be light sensor. Digital accelerometer is another sensor of another type of digital sensors. And if you remember any other type of digital sensors, mention them in the comments below as well, because there are hundreds of type of sensors which are present in the market these days, and these sensors cover so broad spectrum and so broad domain and application in which we can use them, right? So now I'm going to discuss about these sensors in particularly based on categories. Like I'm going to differentiate the sensors who work based on temperature, proximity, water quality sensors, and etc. So the temperature sensors are first, and you all know the temperature sensors, right? They are used to measure amount of heat energy in whatever environment they are being operated in. There are thermocouples, the sensors that show a change in the voltage based on the temperature. They are thermocouples, and as temperature go up, the output voltage of the thermocouple will also go up. Then you have RTDs. RTDs stand for resistor temperature detector. So the resistance of this device is directly proportional to the temperature. So when temperature rises, the device resistance will increase, and when it falls, then the resistance will also fall. Then you have the thermistors. So thermistors are basically the temperature sensitive resistors that changes its physical resistance with the change in temperature. So basically they are all doing same thing, but following different ways. Like IC, integrated circuit, or different type of semiconductors. So what are they? They are basically linear devices where you can where the conductivity of your semiconductor device increases linearly, and you take advantage of that variable resistance properties of your semiconductor materials. Then you have IR sensors or infrared sensors, which detects temperature by intercepting a portion of emitted infrared energy of whatever object or substance, and it senses its intensity. And it can be used to measure temperature of solid or liquid or even plasma, right? And probably most of you have saw this uh, IR sensor used in the COVID pandemic in order to check the body temperature of people, right? When you go for RT-PCR test, we use IR sensors to check body temperature. Then we have the proximity sensor. Proximity sensors are used to detect the presence or absence of the nearby object in its properties. So the example of that first one is the inductive sensor. Inductive sensors are used for finding the presence of metallic object using electromagnetic field or a beam of electromagnetic radiation. Then you have capacitive sensors. Capacitive proximity sensor can detect both metallic as well as non-metallic objects. Then we have photoelectric sensor. Photoelectric sensors is made up of light sensitive parts, and it uses a beam of light to detect the presence and absence of an object. And ultrasonic sensors are used to detect the presence and absence of an object to measure the distance of target, similar to radar or sonars. And if you have seen a proximity sensor of your phone has one, your smartphone that in which you are watching my video currently, that has the proximity sensors. And if you have noticed it or not, whenever you talk to somebody on the phone, whenever you bring the cell phone close to your ear, the display of your phone will get turned off, right? Why? because your call is in the process and you don't need to see the display. And what would does it? So your proximity sensor does it, that it will sense that okay, call is going on and that person is talking to somebody. So whenever your phone is close to your ear, it will sense okay, the distance between the phone and that person is uh, continuous, and call is also ongoing, so it will turn itself off. But as soon as you change the distance between phone and yourself, or phone and your ears, the phone will light up. So that is a result of proximity sensor. Then you have the water quality sensor. These sensors are used to detect water quality and in order to do the monitoring of ion, and they're basically primarily used in the water distribution systems. So in that you have the chlorine residual sensor, which measures free chlorine or monochloramine and total chlorine in the water. Then you have total organic carbon sensors, which is used to measure the organic element in water. We have turbidity sensors, which measures the suspended soils in the water. We have conductivity sensors, which measure and the conductivity measurements are carried out in the industrial process primarily in order to obtain information on total ion concentrations or dissolving compounds in the water solutions. So they use conductivity sensor in it. Then you have the pH sensors in order to measure the pH level of dissolved water, which indicates how acidic and basic nature does the water holds. And then you have the oxygen reduction potential sensor, or in short it's sometimes called ORP sensor. So the ORP sensor measurements provide the insight into the level of oxidation or reduction reaction occurring in the solution. So it can tell you if oxidation process is occurring or reduction process is occurring, and how far it has been done. Then by the way, the video has been stretched out far longer, so I will not explain every sensor from now on. I will just pronounce their names and then we will move to the actuators. So we are having chemical sensors. They are used to measure the chemical reactions and changes, like chemical FET or chemiresistors, electrochemical gas sensor, fluorescent chloride sensor, hydrogen sulfide sensor, non-disparative IR sensors, pH glass electrode, potentiometric sensors, or zinc oxide nanosensors. Then we have the gas sensors, which are similar to the chemical ones but specifically used in order to monitor the changes of air quality and then detect the presence of different gases. Right. Uh, the example of this type of sensors are CO2 sensors, carbon monoxide detector, breathe analyzer, catalytic bead sensor, catalytic bead sensors, hydrogen sensor, air pollution sensor, nitrogen oxide sensor, oxygen sensor, ozone monitor, electrochemical gas sensor, gas detector, right? Hygrometer. So all these sensors are gas sensors. Then you have different actuators. So because video has been stretched out a little too long, so let's discuss about actuators in very brief and then we will wind it up. So at high level, we can classify actuators in five different types, which can be as given. It can be hydraulic, it can be pneumatic, it can be electric, it can be thermal or magnetic, and it can be mechanical. So the first one is the hydraulic. So in hydraulic actuator, a cylinder or fluid based motor uses the power of hydraulics to create mechanical action, and that motion can be either straight or it can be rotating, it can be oscillating, it can be different, it can be uh, vary, right? Then you have pneumatic, and with pneumatic actuator, a vacuum or compressed air is used to make energy into the action, and they're good for making a large linear or rotating motion with a small amount of pressure. Then you have electric actuator, and electric actuators are most commonly used, by the way, but they're not require they don't require any specialized mechanism in order to operate. So these actuators work on electrical energy, and they turn it into mechanical energy. So there will be, you will see so many IoT devices using electrical actuators. Then you have thermal actuators. They are sometimes called SMM actuators as well, shape memory alloys. They create high power density energy for commercial applications. Then you have the mechanical actuators, and most of you will be aware of them, using pulleys or gears, rails and chains. So these a mechanical actuator will convert rotating motion of physical object into linear motion. And one of the major example of that is rack and pinion steering system, right? And now let's discuss about some of the widely used actuators. The one I just told you about, linear actuator. So linear actuators are used to enable the motion of the object or element in a straight line. So if you have familiar with unmanned ground vehicles or UGVs, they use linear actuator in order to keep your vehicle in one line, or to follow a lane. Lane follower is also one of the name of linear actuators. Then you have the motors, which we use to uh, we used for almost every purpose, right? So used for precise rotational movement of devices, components, or the whole objects itself. Then we have the relays, which are used for operating power switches in lamps, heaters, and even smart vehicles. And then we have the solenoids, which are most widely used in the home appliances as a part of locking and triggering mechanisms. And they also act as controlling in IoT based gas and water leak monitoring system as well. So these are different type of actuators, and these are some of the very popular actuators which you and I use on day to day basis. So that would be it for actuators. We will wind up this class today. We will wind up this class right now, and next time we will meet, we will discuss about Arduino. So it will be very interesting, and it will be very enthusiastic to discuss about it. So I will be seeing you next time. If you have any doubts, queries, questions, feel free to mention them in the comment section below. If you have any feedback related to the channel or lectures, you can mention them as well. I will try to answer them as soon as possible, and as many as possible. And uh, I will be seeing you next time. Thank you very much for listening. Take care of yourselves, and goodbye for now. Thank you very much.